Okay guys, in this video, in this do it with me video, I'm going to do a few differentiation rules questions from past papers, and I encourage you to do it with me. There's going to be a few of them, but it should be short because it's quite, I don't think it's going to be hectic. I don't think so, but let's see what happens, shall we? All right, here's my example. F of x equals 2x3 minus 3x. Okay, so from first principle, no, we're not doing first principles. I just made that video. I am not going back. Okay, so what you got to do is it's your exponent times your coefficient. So the thing at the top times the thing at the front. So I've got a 3 and a 2, easy peasy, gives me 6. And then your exponent changes. It becomes whatever this guy is minus 1. So we have 3 minus 1 gives me 2. Okay, minus, and now we have a 3 here, but there's nothing there. Now, you have to remember, mathematicians are lazy. So at the top over here, there's actually an invisible 1 that nobody bothers to write. They're just like, you're supposed to know it is there. So we're not going to write it. Good luck to you. So we have 1 times 3, or actually it's 1 times negative 3, just gives us negative 3. What? I thought I changed that. No, I did not change that. And then we have 1 minus 1. So we have x to the 0. But you know from your exponent rules, which you've studied really hard and you know them really well, right? X to the 0, or anything to the 0th power, is just 1. So technically over here we have 3 times 1. And like I said, mathematicians are lazy, so we are not going to write that final 1. Bam. There's our answer. Okay, I'm going to leave that guy right where he is. And I'm going to give you the next one. Okay, so we have d of x, funky bracket, 3x minus 5x squared. Let's just talk about the different ways in which they can say, please find the derivative. When you see this, they're asking you to differentiate. All right, so this is, please find the first derivative of everything in there, or derive everything in there. So that would look like we have our invisible 1 times a 3, gives me 3. This one is just 1 minus 1, which would be 0, which is 1. And no mathematician is going to bother writing that. So we move on to the next one. Over here, I have negative 5 times 2, which is negative 10. And this guy is 2 minus 1, so we have x to the power of 1. But I'm not going to write that because I'm lazy. We have d of x, derived with respect to x, square root 4x6 plus square root 2x, and the x is outside the, they put a little dot there in the paper. This just means multiply, and it's just a way to make clear that the x is not inside the square root. Okay, this one's not quite ready to start deriving. When you want to simplify your x as much as possible, and right now it's inside a square root. So our next line is simply going to be d dx. And now we're going to simplify. The square root of 4 is 2, and the square root of x to the power of 6 is x to the power of 3. Why is that? Please remember from your exponent rules, x in a square root is basically x to the power of a half. So if you have x to the 6 inside a square root, you have x to 6 over 2, which is just x over 3. You got to know this. You got to know this. So if you didn't know this, write this down somewhere and go and study your exponentials. 2 times x squared. All right, now we're ready. So our derivative is just simply 2 times 3 is 6. This one is minus 1. 2 times square root of 2 is 2 square root 2 times x. 2 minus 1 is just 1, which we're not going to write because we're lazy and we're allowed to be. So there we go. Okay, another funny way of writing it is d of x, capital dx. It just means the derivative with respect to x, which is just a funky way to say find the first derivative. So we have 7 square root x2 plus 2x minus 5. Okay, first we have to simplify a little bit. D of x, 7. So square root of x to the 2, you can either do what we just did, which is basically like x is 2 over 2, which is just x is 1, which we're not gonna write the 1, or you can just say, hey, this squared and a square root are each other's opposites, so let's just delete that stuff. All right, so then I have x, and I don't write the 1, and this one is already ready. Sure, our derivative straight up is just 1 times 7 is 7, 1, and this will be x to the 0, so it's gone, plus 2x to the, no, blah, 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 I don't know, my brain just went doo doo, bye. Negative 5 times positive 2 gives me negative 10. X to minus 5 minus 1 is minus 6. Okay, I'm going to pause here for a moment because I really want you to see they ask for the derivative in a few different ways, and on this board is exactly what your answer is supposed to look like. I don't know why they want you to know this in high school, but it's here, and you know what? Just go ahead and study it. Like, we have a d of x equals square root negative e to the 3 x over 2 plus 1 over 3x in brackets squared die. All right, pause and try. Okay, I'm going to put in one extra step just to make my life easier. And remember how I said, like, sometimes it's helpful to have the x, to separate the x from its fraction. So we have the 2 under the line. There's nothing besides the cube root of x, so that's a 1. And then the cube root of x is x to the power a third plus 1 squared is 1, 3 squared is 9, and that's x squared, but we don't want it under the line. We still have d of x equals negative a half x cubed, and we have 1 over 9 x to the negative 2. Wham. Now I can derive, so a third times a half gives me negative a sixth. And then I have a third minus 1, which is just 3 over 3, gives me negative 2 over 3. Negative 2 over 3. And then I have negative 2 times positive, give me a minus. 2 times that is negative 2 over 9. And x is just minus, so it's minus 3. Okay, if you want to be hardcore, you can stop at this stage, but if you want to flex, you can do this and say, okay, I have x squared and a cube root, and over here I have negative 2, 9 over x to the 3. Ta-da! All right, we have 3 more. Okay, they give us g of x equals 3x to the 4 minus 4x squared plus 6 over x squared. Okay, we can't derive that yet, so we're going to split it up. We have 3 over x to the 4 x squared minus 4x squared over x squared plus 6 over x squared. My favorite part in all of math. No, I want the green. This one is die. Here remains a 2. This one is just flat out dead. Nothing can happen here. That last one was real boring. So we end up with 3x squared minus 4 plus 6x negative 2. We apply our differentiation rules. 2 times 3 gives me 6x to the 1. This one disappears because he has technically an x to the 0 and 0 because that's a 1. And 0 times negative 4 is 0. So poof, gone. Bye. And then we have negative 2 times 6 is negative 12. X to the negative 3. And if you're going for the flex, that would be 6x minus 12 over x to the 3. Like I said, you can stop here. But if you want to flex, you are welcome. And second last one, g of x equals square root x plus 3 over square root x minus 1. Okay, you cannot factorize if stuff are in parentheses, so we gotta deparenthesize them. That is not what it's called. We gotta simplify them, but I like that word, deparenthesize. I wonder if anybody in the history of mankind has ever said that word. Probably yes. I would like to meet them and buy them a coffee. So x times x, both of which to the power of a half, we just add those, so that becomes x. Then this one times that one gives me negative x to the half, power of a half, and then that one gives me positive 3x to the half, and that times that gives me negative 3. Continue. Plus, this is minus 1 of those, plus 3 of those gives me positive 2 of these, minus 3. And now I can find the derivative. G prime of x equals, that's just going to be 1, because it's 1 times 1, and 1 minus 1 is 0, and blah, 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 you know. Then I have a half times 2, which is just going to be 1. And then I have to minus 1, and you can either throw that in your calculator or just go, I have half a pizza, but I want a whole pizza, so I'm like still hungry for half a pizza. And the 3 disappears. So that you can flex, but you can stop there. This would be 1 plus 1 over square root of x. Wow, we're doing so well. Almost done. Okay, this one, I haven't seen a lot of them in past papers, but they can ask them, and since I found it in a past paper, here we are doing it. And then they added x does not equal minus 3 over 2. And now your brain might want to freak out about this, and you just tell them, brain, bring me a better thought. We're just going to think about it. I'll show you why they said this. But the question literally said, let me just make some space. The question literally said, find the first derivative of x if, find this if f of x equals this business and that's all that stuff. and then x minus so that's what the question looked like. And like, if I'm gonna be honest, I was also like, why? What's happening here? Why are they doing this? And then I realized, and I was like, oh, that's so dumb. I'll show you. We can't derive this yet. It needs to be flattened. That is not a technical term. One of my students made it up, and I like it, so I'm just gonna do it. This guy, that's a perfect square, that's a perfect square, that's a perfect square. So we have a difference of squares, which gives us this minus 3 and this plus 3 over, and I'm going to factorize here as well, but this time just a common factor. Gives me 2x plus 3. Ah, my favorite part. Die. So now I have if x equals 2x minus 3 over 2, and we've learned to split this up. So this becomes 2x over 2 minus 3 over 2. And that's it. Okay. So die, and then we have x minus 3 over 2 is my f of x. Oh, no. What am I doing? Is my f of x. There we go. All right, so here's why they put this in. If x had been equal to negative 3 over 2, and you substituted that into this, so 2 times negative 3 over 2 plus 3, this times this, 2 times that will give me negative 3 plus 3, which is equal to 0, and then you'd be dividing by 0, which we're not allowed to do. They just put that in to make the question legal. So that's why you shouldn't worry about it. Anyway, let's derive. So we have the first derivative of x. This is just 1. Wow. All that work for just that. But that's it, guys. That's all I've got for you for this one. So have a nice day.